All right, hello students. So this is the second activity that we do to get started with our quadratics unit, and we're looking at an activity where we're trying to model something that we haven't been able to model yet this year. All of our functions so far have been linear or exponential, and now we're looking at the new thing, quadratic. And here we're trying to make the line that goes through the points the best fit line. And I think it looks something like this, where about half the dots are above it and the other half are below it, kind of goes through it right there. And that looks pretty decent for those points that I see right there. However, it turns out that those dots were actually the first couple moments of a basketball shot. And obviously, the line is not how a basketball flies through the air. The basketball starts to go back down. And so the line is wrong because it goes up at a constant rate, and we need something that goes up and then starts going back down. As we move here, we're going to learn about a new curve, not a parabola and not a line, excuse me, and it's called a parabola. So the word quadratic is technically what we use for the equation, and the word parabola is what we use for the graph. You can pretty much just change them back and forth. So parabola, quadratic, those are pretty much the same thing. All right, and then after the beginning slides, you're really just watching these short clips here and making predictions about whether the ball will go in or out. This is the same sort of idea that you will do in your projectile project. You will take a short video and try to find the exact equation that models the shape that the ball takes or whatever object you are throwing as it goes through the air. So there we go. That one looks like, to me, it's not going to go in. That one looks short. Now we get to actually model with parabolas, with quadratic equations here. What I want you to notice is this one point that I drag around here is the most important point on the whole graph. This point is called the vertex, and this is the point that determines the highest or the lowest point of the graph. So I'm going to put the vertex right about here because that looks to me pretty close to where the highest point of the graph is. And I'm just going to put the other point right where the ball gets released, which is the y-intercept, where x is equal to 0. And then that looks like it models the path of the ball. And so using that model, this one looks like it's going to go straight through the hoop. You can do similar sort of things where you're putting the vertex and putting the y-intercept like that. That one doesn't look in, etc., etc. Then you get to actually watch the reveals. It's more fun if you try it yourself. So I'm not going to reveal anything. And then the last couple slides are pretty important for understanding what's going on here. Whenever I ask you about the beginning, we're talking about the y-intercept right here. And the y-intercept, and this is extremely important, the y-intercept, as soon as you hear y-intercept, you should be thinking of the beginning, and you should also be thinking that the x value is equal to 0. These ideas need to be linked up in your head, that when you hear x equals 0, you automatically think of y-intercept, you automatically think of the beginning. When you hear y-intercept, you think of the beginning, you think of x equals 0. And so when I look at this, it looks like the shooter is about 6 feet tall. And that's a point on the graph that is 0, 6. So you notice how the x value is 0 and how the y value is the y-intercept. On slide 19, we can find the coordinates of the basketball hoop. I would estimate that the coordinates of the basketball hoop are right there in the middle of the hoop would be something like 19, 10. And that just means that it is 19 feet away from the shooter and that it is 10 feet high. Because that's what the x and the y coordinates stand for on the graph. And the last slide is extremely important. We're going to spend a lot of time working with this type of equation here. And I want you to notice these coordinates right here are right there in the quadratic equation. And if you look for where those coordinates are, it's right here just a little bit past 10, right here a little bit above 14. And that is that point I was talking about earlier, that it's the vertex. So notice that in the equation it wrote x minus the vertex, and then outside parentheses is plus. And that right there tells you the vertex. In general, you're going to have equations that look like this. And the important thing to remember is that the x value is inside the parentheses, the y value is outside the parentheses. Something we'll work on, and I'm not going to spend time talking about it right now, is why is it subtracted on the inside of the parentheses and added on the outside of the parentheses? The idea comes back to what the number 0 does and why the number 0 is important, but we're not going to spend time dwelling on it right now. For now, all I need you to take away is that the vertex is the most important point, and one way of writing quadratic equations, called vertex forms, tells you the vertex just by looking at the x and the y coordinates that are in the equation. So thanks for watching. Please ask questions, comment if you need anything, and I will help out.